Hey guys, today we're going to do section 10.5, tangents. Okay, so let's take a look at this picture here before we talk about what each of these keywords mean. So we have a picture of a circle, and what a tangent is a line that touches the circle at one point. It doesn't go inside the circle, it just touches it on the outside at one point. So line AB is your tangent. The point where it touches the circle, like point A, is called your point of tangency. So point A is your point of tangency. So let's write down those definitions. A tangent is a line that touches the circle at exactly one point. One point. So the tangent in this picture would be line AB. Remember, point A is the point of tangency. And that's the point where the tangent touches the circle. So our tangent is a line that touches the circle once, and the point where it touches the circle, like point A, is the point of tangency. So let's take a look at Theorem 1. Theorem 1 is a line is tangent to a circle if and only if the line is perpendicular to the radius. So that's not a misspelling there. That means if and only if. So a line is tangent to a circle if and only if the line is perpendicular to the radius. So in here, they're talking about if we had a radius drawn in, if we have a radius drawn in here, it would be tangent if we knew where that radius is, if there was a right angle drawn in here. So perpendicular, remember, means makes a right angle. All right, makes a right angle. So let's take a look here. So we want to figure out if KL is a tangent. So KL is part of a line that would be a tangent. So Theorem 1 says if we have a radius here, if this is a right angle, then KL would be tangent. So the way we would check this and to see if this would work is we'd have to do Pythagorean theorem. So we'd want to use a squared plus b squared equals c squared. If we plug the numbers in and it works out, then this would be tangent to the circle. So remember, this would be our hypotenuse. This entire piece right here would be our hypotenuse. Let me trace that over here. Also, let me plug in for a second here so that my phone does not die. There we go. Okay, so if we plug in 8 and 15 for A and B, 8 squared plus 15 squared equals c squared. Well, c would be our entire hypotenuse here. But the problem is they only tell us from here to here is 9. How much would it be from here to here? Well, let's take a look. This is a radius. This is also a radius. So if this radius is 8, this radius is 8. So now we have to say how long is this whole piece going to be? Well, 9 plus 8 is 17. So the whole length, let me write it in orange, is 17. So that's what's going to go in for our hypotenuse for c squared. All right, so 8 squared is 64, 15 squared is 225, and 17 squared is 289. All right, so let's add here on the left, and we get 289 equals, oh, I should have made that a 9, sorry, equals 289. So we get a true statement. So we write yes. Is KL a tangent to the circle? Yes, because Pythagorean theorem worked out. So let's try it again over here. So we're going to do Pythagorean theorem. A squared plus b squared equals c squared. 8 and 6 are going to go in for a and b. 8 squared plus 6 squared equals, this would be the hypotenuse. All right, now this time they gave us both numbers. Ooh. All right, so 12 and 6 give us 18, so that's what's going to go in for c squared. All right, so 64 plus 36 equals 324. So 64 plus 36 equals 100 equals 324. Is that a true statement? It is not a true statement. So, no would be our answer. HF is, I'm sorry, GH is not tangent to circle F. All right. Now, let's take a look down here, A and B. So they're a little bit, they're the same, but they're a little bit more challenging. So let's take a look here. Let's look at A. So we're still going to do Pythagorean, well, we can still set up Pythagorean theorem here. A squared plus b squared equals c squared. A and b are going to be our x and our 12. X squared plus 12 squared equals. Now, this is our hypotenuse, GH. From K to H is 8. GK is a radius. This is our radius. This radius is X, so this radius is X. What we did in the above problem was we added those two pieces to get the whole length. So we have to do the same thing here. When you add these, you get X plus 8. So that's what's going to go in for our hypotenuse, X plus 8. Put in parentheses with the squared. Here's where it gets a little bit different. X squared plus 12 squared is 144. Remember, back from algebra, when you're squaring something that's being added inside a set of parentheses, it really means x plus 8 times x plus 8. Rewrite the left side, x squared plus 144 equals, here's what we have to do here when I write this word. FOIL. Remember FOIL from algebra? We have to multiply our firsts. X times x is x squared. Our outers, x times 8 is 8x. Inners give us 8x. And our last, 8 times 8 is 64. Okay, rewrite the left. All right, let's simplify the middle. X squared, 8x plus 8x is 16x plus 64. All right, now let's get rid of our x squared. If I subtract my x squares, they end up going away. So I have 144 equals 16x plus 64. All right, so let's bring the 64 to the other side. 144 minus 64 is 80 equals 16x. Divide by 16, x equals 5. That's our answer there. All right, now let's take a look at B. When I look at B, all right, there's a problem. I have an x and I have a y, so we can't set that up exactly like we did these other three problems. However, this number jumps out at me. All right, it's saying if JH is tangent. So if this is tangent to the radius, I know I have a right angle here. And if this is 30 degrees and that's 90 degrees, this is 60 degrees. So we have to use our 30, 60, 90 rules. So if we remember our 30, 60, 90 rules, this actually becomes fairly easy. This is our hypotenuse, all right? This is our short leg, this is our long leg. Short leg, long leg. Remember, the short leg is half of the hypotenuse. So x will equal 6. I did 12 divided by 2. Y is the long leg. Whatever my short leg is, I multiply it by root 3. So it's 6 root 3. All right, theorem 2. I kind of call these the like sideways ice cream cone problems. If you have tangents from the same point, so we have a tangent AB and a tangent CB. They're both connected to point B. What happens is those two pieces become congruent. AB is congruent to BC. AB is congruent to CB. So you just set them equal. So when you see like an ice cream cone problem like this, all you have to do is set them equal. All right, so let's take a look. Set them equal. X plus 15 equals 2x minus 5. Subtract our x, subtract x. We have 15 equals x minus 5. Add our 5, add our 5. 20 equals x. Find the value of x. All right, easy peasy. B, find x. Assume that the segments appear to be tangent are tangent. So they're telling you we can assume that these pieces are equal to each other. 3x plus 8 equals 26. Subtract 8, subtract 8. 3x equals 18. Divide by 3, x equals 6. These give us units, so I'm going to put 6 centimeters. And that's it for tangents.